Alright, this is Mr. Lundy again, and this is video number 3 over polyatomic ion naming. Our first video, if you remembered, we covered binary ionic naming, so we were naming a metal, specifically a always metal with a nonmetal, so that was our group 1 or group 2, also our bing mixed with a nonmetal. And then in our second video, we talked about naming a either or metal or a transition metal, those are metals from the periodic table, and bonding that with a nonmetal, and that was also a type of ionic. Today we are going to be talking about ionic naming with polyatomic ions, and so this is our level 3 Jedi Knight Obi-Wan level. So you can flip to that section in your guided notes. But to start out, we'll talk about polyatomic ions. And these are groups of nonmetals that form a cohesive ion. So in this one, we'll be using both our always metals and our either-or metals. But instead of bonding them with just one nonmetal, we are going to be bonding them with a group of nonmetals that are bonded to each other. And if you've been studying your polyatomic ions, those are the list of grouped nonmetals that you've supposed to have been studying. They come together, they have a charge at the top, and they also have a name. So if a polyatomic ion is present in a compound, it is known as a ternary compound. And so we have binary compounds. And we talked about how binary compounds use the suffix "ide" at the end. So you use the metal, and then you have the nonmetal, and you change its suffix to "ide." But in a ternary compound, there is no "ide" at the end. The exception to this is hydroxide, which you have hopefully studied on your list of polyatomic ions. But instead of using the name of the nonmetal with an "ide" put on the end, we are actually just going to write out the name of that polyatomic ion. So if you look at our first example, we have FeNO3 2. And so we start out by looking, we know we have a metal here, it's a transition metal, we know that's iron, and it's a transition metal, so we need to put our parentheses in. And by memorizing our polyatomic ion chart, we know that this NO3 here in the parentheses is nitrate. Now this 2 here, this just says that we have 2 nitrates, but this NO3, this polyatomic ion, comes all as one set. Just like you would see in the binary compounds, a nonmetal coming by itself and bonding with a metal. This is like a super element or something like that. It's its own compound, and now it's going to bond to make a even bigger compound. So this is called nitrate, and we know that nitrate has a -1 overall charge. So if we know that it has a -1 overall charge, we are trying to get to 0. There's 2 of these, so we have a -2 over here. It means we need this to be a +2. So if that's a +2, we know that we have iron 2 nitrate. Alright, for our next one, we start out looking at our metal. We have magnesium. And we have PO4 here. Again, that 2 there is just telling us that we have 2 PO4s. And the name of that PO4 is phosphate. So for that one, we have magnesium phosphate. And since magnesium is one of those group 1 and group 2 elements, we don't have anything in parentheses there. It's an always metal. For the next one, we start out by writing out our metal name. It's copper, which we know is a transition metal, so we're going to have to put our parentheses in here. And SO4, you could draw some parentheses around there. It would have pretty much a invisible 1 here. There is a 1, but we don't write it out because we don't have to write out 1s. But that SO4, when it comes as a group, is called sulfate. So we have copper parentheses sulfate, and we know that our sulfate has a -2 charge. So if we know that our sulfate has a -2 charge, and we're trying to get to 0, we know that our copper must have a +2 charge. So if we add those together, we get 0. So this is copper 2 sulfate. Okay, so now we're going to try going the other way. We are going to start with our name, and we are going to write out our formula. In our first example here, we have copper 1 carbonate. And we know that our symbol from copper from the periodic table, Cu, and by looking at our polyatomic ion chart for carbonate, we know that the symbol for that is CO3. Now copper, it tells us in the name, has a +1 charge, but if we look at our polyatomic ion chart for carbonate, we know that we have a -2 overall charge here. So if we want to balance this, we set it equal to 0. We want this side to equal +2 so it can balance out our -2 on this side. And we know that we need 2 coppers to balance out our 1 carbonate. So that means when we write it out, we have Cu2CO3. For our next example, we have silver nitrate. We look at our periodic table. Silver is Ag, and nitrate on our polyatomic ion chart is NO3. So from our bing, 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 we know that silver is a +1 charge. And looking at our polyatomic ion chart, we know that NO3 has a -. So for this one, we'll kind of use our crisscross method. Up here we balance it out, but we'll kind of cheat and use our crisscross method. We'll bring our 1 down, we'll bring our 3 down here, and we will get AgNO3. And for our last one, we actually have 2 polyatomic ions coming together to form a compound. So ammonium, that's the only positive polyatomic ion that you have to memorize. But if you look on your polyatomic ion chart, ammonium is NH4, and sulfate is SO4. So the first thing I'm going to do, I'm going to draw some parentheses around NH4 so we know that's all one thing blocked together, and we don't confuse where one polyatomic ion starts and where when it stops and when the next one starts. So if we look at our polyatomic ion chart, we know that NH4 has a +1 charge, and we know that SO4 has a -2 charge. So we know that if we want it to equal 0, we're going to have 2 NH4s for every 1 SO4 to balance it out so that we can equal 0. So we put a 2 at the bottom here, and then we end up having, in parentheses, NH4 2 SO4. And that is ammonium sulfate. So that is it for ionic naming. Again, we had our 2 types of binary ionic compounds. That was our always metals and our transition metals. And now we've learned how to name an ionic compound with a polyatomic. So our next section, we will be talking about covalent compounds, which is when you bond together 2 nonmetals.